Module 1, Lesson 17, we're going to look at an idea that involves equations where the expressions have already been factored. So the outcomes are going to be to demonstrate an understanding that equations in the form a minus x times x minus b equals 0 have the same solution set as two equations joined by the term or, whereas x minus a equals 0 or x minus b is going to equal 0. And then we want to take a look at some equations where we're going to solve that have already been factored or need some minor factoring to be solved. So really, the whole idea behind this idea is the fact that a student needs to understand that anything times 0 is going to equal 0. So for example, if we said 4 times 0, we know that that's going to equal 0. So the idea is if we had the x minus the a times the x minus the b, it goes in to say that if this ended up being 0 times whatever was in this parentheses, we would still get the answer of 0. And so we want to play off of that notion that 0 times anything is still 0 amongst all these expressions. So in exercise 1, one of the examples that was looked at in class is to consider the equation x minus 4 times x plus 3 equals 0. And so they want us to understand this notion of or and to rewrite the equation as a compound statement. So in doing that, we will end up writing x minus 4 equals 0 or x plus 3 will equal 0. The emphasis on the or. Again, because if either one of these things goes to 0, then the entire equation will go to 0. So generally at this point what the students are doing is they're going to take this x minus 4, set it equals 0, add 4 on both sides. So they know that if x were to equal 4, then this whole piece here would go to 0. Likewise here, x plus 3 equals 0. So if I subtract 3 on both sides, x will equal to negative 3. And so if I had put a negative 3 into this x, then negative 3 plus 3 would equal 0. So what are the two solutions in this design? X equals 4 or negative 3 would make this particular equation completely go to 0, which is, again, the whole purpose of this lesson, lesson 17. If we look at this example here, 2x squared minus 10x, the student is going to pull out a greatest common factor to where you end up with a 2x, and then on the inside I will end up with an x minus a 5, and that's equal to 0. So if we were to break our compound under the design here, we would have 2x equals 0 or x minus 5 is going to equal 0. So if we solved each one, we would divide both sides here by 2, and so x would equal to 0, or if we added 5 on both sides, x would equal to positive 5. So our solution set is x would equal 0 or x equals 5. Either way, this entire equation would equal to 0. When we're looking at this piece here, what the teacher's hoping that the students identify is the fact that we have an x minus 3 here and an x minus 3 here. That's, in a way, is known as the greatest common factor, or something that both terms in particular have in common. So if they both have it in common, I can say that GCF is x minus 3, and what's left over if I divide it is the x, and then this other one, the plus 5. So we see this factored notion where we would say x minus 3 equals 0 or x plus 5 will equal 0. So if we add 3 on both sides, x would equal to 3. And if I subtract 5 right here, then x would equal to negative 5. So then our answer would be x is equal to 3 or x is equal to negative 5. Both of these cases would make the equation equal to 0. In exercises 2 through 7, the teacher is having the students continue this notion or this practice of individually or on whiteboards where the partners solve these particular problems just to get a better idea as we go through. So to look at some of them, if I split this up, which is where the teacher would want them to go eventually, would be to put a line down there, set each one equal to 0, and then solve each one independently. So you would end up with x equals negative 1 and x equals negative 2. Same thing if we look at problem number 3. If we split it up, we have 3x minus 2 equals 0 and x plus 12 equals 0. So in this one, if I add 2 to the other side, you get 3x equals 2. And if you divide by 3, x will equal to 2/3. This one we would just subtract 12 to the other side, so x will equal to negative 12. In number 4, you notice the same thing twice, so we are going to set x minus 3 equal to 0 and x minus 3 equal to 0, and so you get x equals 3 for both problems this time. In number 5, we'll do a split here and a split here. So x plus 4 equals 0, x minus 6 equals 0, and x minus 10 equals 0. So in solving, x equals negative 4, and this one x equals 6, and this one x equals 10. And so the idea is if I had a negative 4, a 6, or a 10, it would again make this entire equation equal to 0. Number 6 and 7 is like a follow-up from the previous exercise for the students to practice again. So if we looked at this, the greatest common factor would be x. And then if I divide x squared divided by x, you get x. And then negative 6x divided by x will be minus 6. So we would split this up right here. This one will automatically equal 0. So if we had x equals 0, the entire equation would go to 0. Or if we solve this one, x minus 6 equals 0 and add 6 on its side, then if x equals 6, that would also make the entire equation go to 0. And for our final example, we'll take a look at, in this particular lesson, here we have that greatest common factor piece again, where in each part of the expression we have an x minus 5 and another x minus 5. And so the GCF is x minus 5, and the remainder is x plus 4. Set each one equal to 0, and when we solve, x minus 5 equals 0, so x will equal to 5, and then x plus 4 equals 0, so x would equal to negative 4.